So when we're actually multiplying and dividing fractions, the rule still applies if they were just regular number values. It's just that now we have variables. So I'm going to do multiplication with you guys first, and we have to remember when we multiply, we do not cross multiply. That's only if you have a ratio or an equation that you do that cross multiplication. Just regular multiplication is straight across. Like if you guys had 1/2 times 3/5, this would become 3/10. You multiply straight across the numerators with numerator, denominator with denominator. So when you guys are multiplying, this really essentially just becomes one big fraction, but you're multiplying everything together. So on the top, I like to make it, my first step is to go from 2 fractions to 1. So I'm going to multiply my numerators together. So 27 times 5. And then when we're multiplying, we have to remember that with the variables, we keep the base but add the exponents. So 5 times 27 is 135. But x squared and x to the 5th becomes x to the 7th. Y cubed will stay, because there's no other y over here to combine it with. So that is the top of your fraction. So for the bottom of your fraction, 3 times 5 would give you, or 3 times 15 would give you guys 45. This is x to the 1st. The x and y are separate. If it were x to the 0, there would not be an x there. There is an x there, it's to the 1st. So that 1 plus 4 makes this x to the 5th, and this will become y to the 4th times y to the 1st. 4 plus 1 is 5. So I'm going to do my variables first. When we multiply variables with exponents, we add the exponents. When we're dividing, we subtract. So x to the 7th over x to the 5th becomes x squared. 3 minus 5 becomes y to the negative 2nd. Now, we have to reduce 135 over 45. Now, I know that they're both divisible by 5. So if you don't know if that's the highest or not, you can at least divide by that. 135 divided by 5, I don't know that one on top of my head either, would give you 27. So if we divide both of them by 5, we would get 27. 45 divided by 5 is 9. So if I'm looking at that fraction, I should be able to see if I took it far enough. But there, I can also see that 27 and 9 would be divisible by 3. 27 divided by 3, or not 3, how about 9? Or maybe you just know that 27 divided by 9 is 3. But this would give you 3 over 1. So, your answer would be 3x squared times y to the negative 2nd. You can write over 1 if you want to. You don't have to. But what we do need to do is move this y to the bottom and make it positive. You guys can't have any answers with negative exponents. So your final answer there would be 3x squared over 1y squared or over y squared. You don't have to include the 1. So when you're multiplying these fractions, just multiply straight across and then reduce. I like to make it one fraction and then reduce that one fraction. So if we're looking at 5 and 6, they are also multiplication, but now we've got pluses and minuses in there. So this is where we're going to have to practice the factoring like we just did on the first page. So if we look at number 6, negative 5x squared plus 20x over x squared minus x. The same idea here, guys. We are going to factor the tops and bottoms of all of our fractions that we have here. So if we just start right with the top one here, negative 5x squared plus 20x. So does anything go into 5 and 20? Yes, 5. And because your first term is negative, I'm going to factor out a negative. I like that first term to be positive. And then if you have x squared and x, you guys can also pull out an x. So that would leave you with 1. You had x squared, took 1 away, so now you're left with x. 20x divided by negative 5 would be negative 4. X take away x, you're not left with any. Okay, on the bottom of our fraction now, x squared minus x. Both of them have an x. There's no common number, but we can pull out just the letter. So x, and this will be x minus 1. X divided by x is not 0. You still need to be left with something there. So anything divided by itself is always 1. Okay, so how about over here? X squared plus 3x minus 4. So we're trying to figure out what multiplies to get us negative 4, but adds to get us 3. So that's going to be positive 4 and negative 1. On the bottom, again, you guys can put that 0x term in there, but what multiplies to get you negative 16 and adds to get you 0, 4, and negative 4. And this should be multiplication. So again, it doesn't matter if one thing is over here and the other one is over here in this fraction, because when you multiply, this really just becomes one big fraction. So anything on the top that is the same with anything on the bottom would equal 1 and can cancel out. So your x minus 1s are the same. They can cancel out. X minus 4 are the same. They can cancel out. Your x plus 4s cancel. So in this case, a lot of things cancel. And x cancel. So it's actually kind of weird because you only end up with a single number, but that is fine. Now don't just get cancel happy and cancel out everything. Do pay attention, but in this instance, the only thing you are left with is 5 or 5 over 1 if you want to keep it as a fraction. And actually not positive 5, negative 5. Keep that negative with it. So multiplication, you're just reducing what you can from the numerator to the denominator. If there's trinomials or binomials, you're going to factor them first. But if it's just like what we did in number 4, I would make it one fraction and then simplify that single fraction.